A very good day to everyone. Today, me and my group are presenting our video presentation on our cloud computing course project, which involves hosting YOLO V8 image analysis model on AWS EC2 instance. We are using collection of remote computing services, which include infrastructure as a service and platform as a service offerings. We are using it because of its global infrastructure, scalability, cost effectiveness, security, and the main reason why we are using it is also its pay as you go model. The particular service we are using of Amazon is the Amazon EC2 instance, which is Amazon Elastic Compute Cloud, which is a web service that provides resizable compute capacity in the cloud. It allows us to create virtual machines on demand and pre-configured templates of Amazon machine images of various operating systems like Linux, Windows, Mac, and etc. AWS offers a free tier for EC2, which includes around 750 hours of T3 micro instances per month for 1 year. Now, the basic architecture of Amazon AWS services works. It offers various services like EC2, EKS, and ECS and all, which are monitored by CloudWatch, which also uses various services like AWS Lambda, DynamoDB, and SageMaker, etc. This is the customer environment of AWS. In the backend, AWS itself uses IBM machines and IBM Instanza software as a service, where it manages its UI backend, stream processor, and its load balancing. And IBM has its own data centers wherein it hosts the data. Now, this is the basic model of our application where we are using an HTML site where we deploy a YOLO V8 model. We here are the user. We are using the website which I mentioned before. And in the backend, we are creating a VPC, that is a virtual private cloud on AWS, which uses elastic load balancing, and wherein it manages the services it provides. Now, these are the reasons why we are using AWS EC2. Like these are the main features, like the instance creation, virtualization, availability of regions and zones, the networking, that is private IP it provides, and instance type storage options, and the most importantly, security, auto scaling, load balancing, and the robustness it provides.
YOLO V8 is a state-of-the-art object detection algorithm maintained by Alteryx that achieve high accuracy and fast inference speed by using single neural network to predict bounding boxes and class prediction. Here you can see the docs of our Alteryx. This is our Flask API to deploy YOLO V8 model. The API input necessary libraries, the Alteryx and other necessary libraries. Now we initialize some configuration for the necessary for API. Now that we can see the predict function, which takes the model as an input and give the images with the bounding box on it. Next is the route, which is to render index.html. The slash predict route is to handle the post request and get request for storing the images and uploading on the server. Next, we have to initialize some command line activities such as model and weights, which load the YOLO model. Next, we will specify the source where the images to be stored. The images are stored in data slash images folder. Next, we will specify the device. You can see that so that we can specify it's run on GPU or CPU. The port for by default is set to 5000, but you can change it. Next, we load our YOLO model. Now our Flash API is ready for the run. We can run it by app.run function is to run the Flask API. Here is the index.html, which is the front end for our UI. Now you can see the below Flask API, which contains the project title, group members, and professor name. The drag and drop function is used to select the image. You can image the selected image by clicking on the upload file button. The handle upload function is used to call the predict function and give the us the output. Now we can run it on localhost. You can see the our API is running. Here is the UI for our front end. Now we can select the image. Click on the upload file button. This is our result of the our model API. Next, we create a GitHub repo using YOLO Flask API. The repo is created. Now we'll initialize the Git repo for pasting this command. Now we will add all the files to the uh, git git commit to save the commit with changing the branch name to main and add the origin, and finally pushing all the code to GitHub. We have used the cloud. Now that has been, we have used the GitHub Cloud so that we can easily access this from our EC2 instance.
So we are in AWS console home. Just search for the EC2 services and just click on the launch instance. I will give it a name YOLO Flask API separated by dash. And here you can see multiple OS provided by EC2. We will choose Ubuntu 24.04 with 64 bit architecture. And we will choose instant type T2.micro and choose only the free tier if you don't want a will. Let's generate a key pair for the login. The key pair name would be YOLO Flask API instance separated by dash. Key pair type should be RSM and the private key file format would be .pem. Key pair is generated. Now modify the networking setting and allow HTTP and HTTPS for the from the internet. And let's modify the security group and set the port 5000. This is where our application will run and source would be anywhere. We will take 16 GB RAM for the YOLO 8 analytics, and this is a free tier and it is valid till 750 hours of T2.micro for 1 month. Let's generate the instance. Yes, instance is successfully generated. Here you can see, but instance status is still pending. So let's reload it. Ha. Here you can see the instance is running and click on the instant ID. Here you can see instant ID, public private address, IPv4 address along with host name, host type and private IP DNS. Here is other sections. Yeah, here you can see two commands to connect with our CLI. Ha. Let's paste first command. Again, let's paste the second command. Yeah, here you can see our instance is connected.
Okay, so let's clear the terminal and let's update the instance to prevent any further errors. Yeah, so let's check the Python version in this instance. It's 3.12.3. And also let's install Python 3 pip, which is the package manager for Python. This will help us manage requirement packages. Now let me get clone the HTTP link of this repository. Yeah, so it's cloned now. So let's move into this repository. Yeah. Yeah, now let me try to install the requirements. As you can see, it's showing some error. It's external managed environment. So we have to install, we have to set up a virtual environment. Now there's some error with the environment because the virtual environment is not installed. So let's install the virtual environment. Sudo apt python 3 hyphen venv. Yeah, so the venv is installed now. Let's set up the venv. No error. Now let's activate the VNV source VNV slash bin slash activate. The virtual environment is activate now. As you can see, the requirements are downloading now. Yeah, so all the requirements have downloaded now. So let's clear the terminal again. Now let's copy this. Yeah, so let's try to run this predict API.py file on device CPU. So as you can see, it's up and running. Now let me go to the instance. Let me copy the public IP address of this instance and let me run it on port 5000 because our application is running on 5000. So let me upload some image. Yeah. So our application is running. Let me upload this cat image. Yeah. So it's giving a response. It's recognizing images. Now if I go to the monitoring section, you can see the CPU utilization has gone up. Network in, out, and packages have gone up. Yeah, so if I copy this link and yeah, so if I do this on Postman, I select another image. save txt capital T and send this. You can see the response time is around 1300 milliseconds. The packet size is 1.83 kilobytes. Now let me send it again. The response time is 1400 milliseconds, and yeah, so for this another image, the response time is 1290 milliseconds. So the average response time is around 1300 milliseconds, we can say. And if I reload this page now, yeah, you will be able to notice that the CPU utilization has gone up and the network in out and packet counts, there's another spike of that because we sent another request from the postman. So these are our teammates. This video is submitted to Dr. Animesh Chaturvedi sir. Thank you.